Hello everyone, my name is NASUHA and today I will talk about gravitational and center force. Gravitational force, as defined by Newton's universal law of gravitation, explains how every object with mass attracts every other object with mass. Newton's law of universal gravitation can be expressed with the formula F equal to gm1m2 divided by r squared. Here, F is the gravitational force, g is the gravitational constant, m1 and m2 are the mass of the objects, and r is the distance between their centers. This force is always attractive and fundamental to our understanding of both terrestrial and celestial phenomena, explaining why objects fall to the ground and how planets orbit the sun. A center force acts along the line joining the centers of two bodies and depends only on the distance between them. Examples include gravitational and electrostatic force. These forces are radially dependent and conservative, meaning the work done is path independent. For instance, Coulomb's law for electrostatic force is similar in form to gravitational law, demonstrating the broad application of central force. Johannes Kepler, through meticulous study and data from Tycho Brahe, formulated three laws that describe planetary motion. These laws revolutionized our understanding of the solar system. Kepler's first law states that planets orbit the sun in ellipse, with the sun at one focus. This elliptical nature means the distance between a planet and the sun varies, explaining the concept of perihelion and aphelion. Kepler's second law tells us that a line segment joining a planet and the sun sweeps out equal areas during equal intervals of time. This indicates that planets move faster when closer to the sun and slower when farther away. This law reflects the conservation of angular momentum given by L equals m dot r square dot d theta over dt. Angular momentum is L equal to m dot r square dot d theta per dt. Area swept is dA equal to 1 over 2 r square d theta. Rate of area sweeping dA per dt equal 1 over 2 r square d theta per dt. So, using angular momentum, which is dA per dt equal to L over m r square, substitute and simplify, so we get dA per dt equal r per 2m. Kepler's third law established that the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit. This means planets further from the sun have longer orbital periods. F is equals to centripetal force mp v square over r. Simplify for velocity, v square equals gms over r. Orbital velocity is equal to pi r over t. Substitute v in velocity and simplify, so we get 4 pi square r square over t square equals gms over r. Solve for t square, which is equal 4 pi square r cubed over gms, and then when r is the semi-major axis A, so we can conclude that t square equal to 4 pi square a cubed divided by gms.
Now that we have learned about the gravitational force and central force as well as the law, we can now take a look at the application of the concept in our daily life. We will explore how satellites stay in orbit around the Earth, focusing on the interplay between gravitational and centripetal force. Gravitational force is the attractive force between two masses. It keeps the satellite pulled toward the Earth. Meanwhile, centripetal force, or also known as central force, is the force that required to keep an object moving in a circular path. So for satellite, this force is provided by gravity. So now we will learn about what is responsible for keeping a satellite in orbit. The first one is a gravitational pull. We know that the primary force that keeps a satellite in orbit is gravity, and gravity is the attractive force that pulls objects together towards each other. In the case of a satellite, it is the gravitational pull of the Earth that acts as the centripetal force. Second, the centripetal force or requirement. So basically, to stay in our orbit, a satellite must move at a sufficiently high speed to balance the gravitational pull of the Earth, and this speed is known as orbital velocity. This means that satellites can orbit around the Earth because they are locked in a speed that is fast enough to overcome the gravity downward force. And other than that is orbital mechanic. Orbital mechanic is the combinations of the satellite tangential velocity and the gravitational force result in the curved path around the Earth. And this path is elliptical if the satellite is in elliptical orbit, or nearly a circular path, the gravitational force acts as a centripetal force, constantly will change the directions of the satellite motions toward the Earth. And lastly is the balance of the forces. So in a stable orbit, the gravitational force pulling the satellite toward the Earth is balanced by the centrifugal force due to the satellite tangential velocity. And this balance allows the satellite to continuously fall toward the Earth due to gravity, while also moving toward tangentially, resulting in a circular or elliptical orbit rather than falling straight down toward the Earth. And next is roller coaster. Roller coaster work by utilizing gravitational force and central force to create a thrilling and yet dynamic ride to ensure that the train stays securely on the track. The forces that involves in keeping the track on the trains are, the first one is centripetal force. Centripetal force is the inward force for an object to follow a curved path. So in this context of roller coaster, this force is provided by the track, which continually changes the directions of the train. Rolls in loop and turns. So in loops and turns, the centripetal force is very essential for keeping the train on the track, and the force is directed toward the center of the curve or a loop, keeping the train from flying outward due to the inertia. And the second force is a gravitational force. Gravity constantly pulls the train downwards toward the Earth, and this force is a key player in converting potential energy to a kinetic energy as the train moving toward the hills. And the third is a balancing act. This track design ensures that the gravitational force and centripetal force are balanced to keep the train securely on the track. So basically, roller coaster leverage on gravitational and centripetal force along with a precise engineering and design to create a thrilling ride while ensuring that the train will stay securely on the track and the rider remains safe. The balance of potential and kinetic energy combined with the physical force at play allow the roller coaster to perform a complex maneuver without falling off the track.
After that, we will look at the problem. There are 4 steps in solving 1A, which is calculate the period of the satellite. For the first step, we need to identify the circular orbit formula. And for the second step, we need to know the Kepler's third law. And for the third step, we need to fill in the circular orbit formula into Kepler's third law. And by having this new formula, we need to know that R is equals to RE plus H, and H is actually the altitude of the Earth's surface. And for step number 4, actually there are a lot of steps in this step, so I will explain the first step in step number 4. The first step is we need to know the orbital radius, which is RE plus H is equals to R, and RE is equals to 6371 km, while H is equals to 322 km. When we combine or add these both number, we will get 6693 km, which is also the orbital radius of the Earth. For step number 2 in step 4, we need to find the orbital period by using Kepler's third law that already been simplified. Therefore, A is equal to semi-major axis of the orbit, while micro is the standard gravitational parameter of the Earth. By filling in all the value into the formula, we will get the period of the satellite is equals to 1.51 hours. After that, we will solve question 1b, which is find the circumference of the orbit. For the circumference, we need to know and remember the formula is 2 pi r. So we fill in the value, which is r, we already get in 1a 6693, and then we will get the circumference of the orbit is 42038 km. And for the last question is 1c, we need to find the radius of the Earth orbit. As we all know, there are 24 hours in a day, which is equals to 86 and 400 seconds. By using Kepler's third law that already been simplified, we fill in all the value into the formula, and we will get A is equals to 42,164 km. As I mentioned before, A is equals to R in 1A. Therefore, R is also equals to 42,164 km.
So what we can conclude here is that gravitational and central force are very crucial in life. These forces ensure not only stability, but also functionality and safety across various applications. From the predictable orbit of satellite to accelerating loop of roller coaster. And by appreciating the principle of these forces, we gain a deeper understanding of natural phenomena and technological marvels that enhance the shape of our world. And that is all from our group. Thank you for lending us your ears.
Next, we will be moving on to Q&A session. So, do you guys have any question regarding this topic?
I do have a question. What is the key characteristic of the central force? Thank you for your question, Ayu. Basically, we have three characteristics of a central force, which is dependence on distance because a central force acts along the line joining the center of two objects and depends only on the distance between them. Secondly, the characteristic of central force is conservative nature because central force are conservative, meaning the work done by the force is independent of the path taken. And lastly, the characteristic of central force is angular momentum conservation. Central force conserve angular momentum about the center of force, leading to predictable orbital motions. I hope I answer your question, Ayu. Thank you, NASUHA. Alright, welcome.
So, any further question regarding this topic?
I have one question, and I want to ask, why don't satellites crash into each other?
I will answer that. Actually, they can. Space agencies and organizations like U.S. Space Surveillance Network continuously track satellite and space debris. This tracking allows for real-time monitoring of satellite position and predictions of potential collision. However, collisions are rare because when a satellite is launched, it is placed into an orbit designed to avoid other satellites. So it is launched far away from one another. I hope that answers your question.
Okay, any more questions?
I have a question. What are the other applications of gravitational and central force in daily life?
The other application of gravitational and central force in daily life are Ferris wheel, satellite in orbit, rotating fans, salad spinner, and tether ball. So I guess I hope I answered your questions.
Thank you.